Welcome back to Solutions. In part 5 of these videos, we're going to be talking about the common ion effect, essentially KSP when a common ion is involved. Let's get started. So the common ion effect is that the solubility of an insoluble substance can be decreased by the presence of a common ion. By common, we mean something that the reaction will have in common. So if I have silver chloride in a beaker and I introduce sodium chloride, there are chloride ions in common. Let's just see how this works. So the first part of this example is not the common ion effect, it's just to get us remembering how to solve KSP problems, calculate the solubility of silver chromate at 25 degrees, and the KSP is given. So the first thing we're going to do is write the reaction Ag2CrO4. And if this thing were to dissolve, this insoluble thing, we'd get 2 Ag pluses and a CrO4 minus 2 ion in solution. So when Ag2CrO4 dissolves, 2 Ag pluses will be formed and only 1 chromate ion will be formed. So my KSP expression is Ag plus squared times CrO4 minus 2, not squared. I can plug in my KSP. 9 times 10 to the negative 12 is equal to 2x squared times x. 2x quantity squared is the same thing as 4x squared times x is the same thing as 4x cubed. Divide both sides by 4 so that the 4's cancel, and I have 2.25 times 10 to the negative 12 equals x cubed. Take the cube root of both sides so that the x cubed cancels, and I end up getting x is equal to 1.31 times 10 to the negative 4 moles per liter. Check your math, make sure your calculator works out to the same as my calculator does, but what I got essentially is saying this is how many moles of silver chromate should dissolve in 1 liter of solution, 1 liter of just plain water that doesn't have any ions in common. So let's see how the common ion effect will affect this. Now we've got the solubility of Ag2CrO4 in a solution that already has silver nitrate in it. So there's already silver in my solution, and now I'm trying to get silver chromate to dissolve in it. It's the same starting reaction, Ag2CrO4, and if it dissolves, it'll make 2 Ag plus and CrO4 minus 2 ion. Now what's different about this problem? We had the x and the 2x and the x, but what's different is there's already 0.1 molar silver nitrate, which means there's already 0.1 molar silver in my solution. So that 2x that here that comes from the silver chromate is not the only silver in the solution. There's also 0.1 molar silver in the solution from the silver nitrate. So that's the ion that the solution has in common. Now the math looks exactly the same. KSP is equal to Ag plus squared times CrO4 minus 2. So we'll plug in those numbers. The same KSP from the problem right above. 9 times 10 to the negative 12 is equal to 2x plus 0.1 squared times x. Now if you look at that for a moment, that's going to end up being not even just a quadratic equation, it's going to be even more complicated than the quadratic equation because there's going to be an x cubed in there. So the common ion effect says that the presence of a common ion will decrease the solubility, which means the 2x is going to be smaller than it was before. So what we can say is that this number, 2x plus 0.01, is approximately equal, 2x plus 0.1, is approximately equal to 0.1, because the 2x should be small. We're going to check it again at the end, but for the moment, this is just going to avoid the quadratic formula. So essentially what we have here, approximately equal to 0.1 squared times x, because we took this term out of it and said that it was too small to matter. So now we can solve this much simpler. 9 times 10 to the negative 12 equals 0.1 squared, which is 0.01 x. Divide both sides by 0.01 so that those numbers cancel, and I end up with x is equal to 9 times 10 to the negative 10 molar. 9 times 10 to the negative 10 moles will dissolve in a liter. That number is really, really small. If you did 9 times 10 to the negative 10 times 2 and added it to 0.01 to check whether that approximation was valid, your calculator is going to tell you added it to 0.1, your calculator is going to tell you the answer is 0.1. That 9 times 10 to the negative 10 is too small to matter, so that approximation was valid. And we'll talk more about making approximations when we get to acids and bases. But for now, what's important to see is that that molarity, or the number of moles that will dissolve in a liter, is significantly smaller than it was on the problem before. On the problem before, 1.31 times 10 to the negative 4 moles would dissolve in a liter, and now it's times 10 to the negative 10 moles will dissolve in a liter. The solubility is decreased when a common ion, and in this case that common ion was silver, but it could be anything, is introduced. And that is the common ion effect. I hope you learned something here, and we'll see you again next time.